Alright, so the first engage activity is going to get us just an introduction to probability. So example 1 says find the probability of rolling a 4 when using a normal 6-sided dice or die with each side having an equal probability. So just in case you've never seen a 6-sided die, it has 1, 2, 3, 4, 5, and 6. And if I roll it, I have an equal chance of having any one of these things turn up. So out of all these spaces, they're asking us how many times does the number 4 pop up? So looking at your picture, how many times do you see 4? 1, right? One result that yields a 4 out of how many sides total? 6. So the probability of rolling a 4 using a 6-sided die is 1 out of 6. You have a 1 out of 6 chance. Now, for numbers 1 and 2, just in case you don't know, cards, there's about this many cards, and yes, you can count up the cards to know the total. And just in case you're not sure, this is what we call a jack, a queen, a king, and then an ace. The rest are just number cards, like 2, 3, all the way up to 10. And they're composed of suits called clubs, spades, hearts, that's an easy one, and last but not least, diamonds. So just keep that as a point of reference in case you see any card problems. And last but not least, for number 2, my hint to you would just be list the number of days in the week. And that'll help you find your probability. Remember, it's going to be your desired result, whatever they want you to find, over the total amount of things that could happen. Okay, just like it says here, do problems in the packet. So you're going to do numbers 1 and 2 right now. Okay, pause here and do that. All right, on the next one, probability of compounded events. So let's say find the probability of drawing a red card. We got some red cards there. Or a black card. And there's some cards there. When the probability of either of these things happening is 1/4. And of course you can only draw one card. So let's say I'm going to draw from all of these cards at least one card, and we're going to try and find what is the probability of either of these things happening. So they do tell me that the probability of this happening is about 1/4 already. If you're wondering, like, how did they get that? Well, we can kind of count and simplify, but let's say they are 1/4 because they already told us that. Let's go ahead and add up. So if it's a red card, we have a probability of getting 1/4 of that happening. Or a black card, that's 1/4 happening. What we're going to do with both of these 1/4 is we're going to add them together. Okay? And the reason I'm using them both because they're both have an equal chance of happening. Okay? So 1/4 plus 1/4, well, we know how to add fractions. What's 1 plus 1? 2. And we don't add these up, so we can reduce, so make sure you're reducing that. And that would reduce to 1/2. Just so you know, for problems number 4 and problems number 5, you can use the exact same setup of adding fractions because they will give you the probability. You won't have to kind of calculate it, which is nice, but you do have to add the probability together and simplify for both 4 and 5. So just like it says here, stop, do the problems in the packet. Okay? And hopefully you did that, because we're moving right along to getting ready for Chapter 20, Conditional Probability and Independent Events. So, in example 1, they talk about find the probability of rolling a pair of sided die. So we're going to roll the This is my picture of a die. 1, 2, 1, 2, 3. So we're going to roll not 1, but 2 pairs of dice. So we're going to roll 2 pairs of dice. So there it is. There's 2. And the sum of their faces being even or equal to 3. So that's important, either one or the other. So I thought this would be helpful to kind of have, okay, well, if I rolled this die and this die, what could pop up? If I rolled 2 other dice, what could pop up? So these are all the possibilities that could happen. So count them up right now, because essentially that's going to be our total for all our fractions, just so you know. And they want to know being even or equal to 3, right? So the sum, where sum means add, so we're going to look at each one of these pairs and see what we get if it's either the sum is a even number, like 2, 4, 6, or 8, or if it adds up to be 3. And we can do a couple calculations, like here 1 plus 1 is 2, 3, 4, 5, 6, 7. Kind of finish doing that on your own. I mean, I'm not going to add all these numbers for you. You can do that on your own, and you can use it for the next couple of problems anyways. But if you did all that, just so you know, there's about 36 total possibilities that could happen. So if you counted all that up, again, I'm not going to do that for you, but all the numbers that are the sums that are even, that would be about 18 of them are even. All the numbers that add up to be 3, in fact, there's only 2. There's only 2 sums that sum up to be 3. And then we're going to subtract to see if there's any differences. So this one's like if it's event A and B. So looking at this, do you see any on this chart, by the way, that would be both adding up to an even number, sum up to an even number, and also sum up to 3? And it feels like a trick question, but I don't see a number here that would be an even number adding up and also 3. Like the only 2 I see is 1 plus 2, and of course 2 plus 3, or I mean 2 plus 1, and neither 3 is an even number. So there exists no numbers, right? That might not always be the case, by the way, for the next couple of problems. But let's go ahead and work this out. What's 18 plus 2 take away 0? 20, right? So that'd be added 36. We can reduce that, by the way, and you should reduce that. That reduces, I believe, to 5/9. If you're wondering how I did that, I essentially just took out a 4 from both the top and the bottom. Alright, moving on. You're going to see something that's different. It's going to feel like they're giving you repetitive numbers, but essentially it's going to be the similar situation. The only difference is you're going to have an or. Either it's going to be an or situation or an and situation. And we kind of went over this, but we're gonna try this out anyways. So let's see if we can find the sum of their faces being an even number, like 2, 4, 6, or 8, or if it's being equal to 3. So let's see. Well, 1 plus 2 equals 3. 2 plus 1 equals 3. Are either of these, because they're only 2, that actually sum up to 3. There's only 2 results. Are either of these, 3 or 3, an even number? No. So that means that essentially, what's a number for nothing? I don't see any numbers that kind of fulfill both of these. 0, right? So that's 0 out of the total possibility, which, I mean, I'm not going to count them up for you, but I mean, you can count yourself. There's 36 possible results. So that would be 0 out of 36 chance. Or if you wanted to simplify that out, 0 chance of that happening. All right. Just like it says here, stop and do the problems. In fact, I gave you a little bit of helper guides because numbers 3 and 4, just so you know, number 3 and 4, have to do with marbles. So if you want to draw a picture, you can. It sometimes helps. For number 5 and 6, if you're wondering, okay, if I toss this coin 3 different times, what are some of my results? So I did kind of find this off the internet, and someone actually did all this for us, so we know what are all the possible results that could happen from tossing a coin 3 times. So use that if it helps for number 5 and 6. All right. And on the next video, we'll be going over 19.1, probability and set theory, by going over some vocabulary. So I'll see you on the next video, okay?